And I just want to add that breast milk is not very well understood broadly throughout the field. And most of the research that's been done over the last 50 to 60 years was done by infant formula companies.
You're just never going to be able to achieve anything close to what human milk can do in the baby's body.
We're running a study ourselves right now, soliciting breast milk samples from the public to be able to assess composition, because it's just not a space that's regulated globally. No one says what should be in breast milk.
Because milk is so different from one woman to the next, and even within the same woman, from morning to night, or even the beginning of her feeding to the end of her feeding, the composition changes. What's the genetic basis for really great milk production when women are able to be overproducers? You know, those very fortunate women who have a freezer full of milk. We want to know what's the deal with that genetically. Breast milk from the breast is really dynamic and highly variable. And that variability is not necessarily something that we'll be able to replicate or capture in a manufacturing process. And so we study closely what are the needs of human infants at different stages in their growth, and are trying to set targets for nutrient composition and contents around what we know to be important.
So let's talk about biomilk and why it is the answer for breast milk. It's not just like it's like the best formula in the world. Like, how do you create human milk without the breast?
We're always very careful to say it's not breast milk because it's not directly from a breast. Our technology was, to Layla's credit, really thinking about how do you discontinue the process of lactation from the need of being in a human breast to instead creating the environment outside of a human breast where human mammary epithelial cells, the cell that line the mammary gland and produce a majority of the macro and micronutrients of breast milk, can construct into a 3D manner where they can synthesize and produce milk outside of the body. So it looks a lot like biologics production, a similar level of biotech, but we're utilizing a human cell that in the body has millions of years of evolution pre-programmed to lactate. So we just have to give it the right environment where it knows its top from its bottom, zipper and tight to its neighbors, and forms a mammary gland layer, essentially. Pulls in nutrients from the media that we feed it in a flow path similar to how it would receive nutrients from the mother's bloodstream, and then secrete milk into a separate chamber so that we can have a pure product that's not intermingling with glucose and nutrients, hormones, the things that naturally would be in the mother's bloodstream from her diet and body. Fundamentally, when you start to break it down, it doesn't sound that crazy. It sounds like pigs flying when you say we're making human milk outside of the body without a human, but these cells are really powerhouses. They can lactate incredibly efficiently, and so we've been learning a lot in the last 2 years around what environment they do best in, what stimulation they need, and how to identify how to get the best compositionally stable product from them with high levels of protein, sugars, fats. We're kind of shepherds. We really take care of them to just produce milk and then, handle that milk downstream to make it a safe product for infants.
Cats seem to not do very much at all. Dogs seem to be incredibly helpful, right? And we don't know why. Got no idea. We've got a lot of hypotheses, but we're not too sure. Or growing up on a farm can be really beneficial. 50% reduction in the likelihood of developing asthma if you're physically interacting with the farm environment in which you live. And the other one is just getting outside and interacting with nature. That's hard for a lot of people, but interacting with a window box and showing a child how to plant with their own food. A little physical activity is incredibly beneficial for the microbiome and incredibly beneficial for your immune system. Sit down on the grass. Do crazy things like stick your hands in the soil. And if I take an antibiotic, then the best way of doing it is to eat a lot of fiber and increase the amount of potentially even fermented foods which are consumed during and up to 2 weeks post-antibiotic therapy.
Kimchi. Hit the kimchi.
Kimchi. Yeah, they don't like kimchi. I love it. But I try sauerkraut, which is really interesting. It's like German kimchi. And so, we do everything we can to increase the fiber content and the diversity of phytonutrients which are present in their diet in order to feed good bacteria so that they can prevent the antibiotic-resistant bad bacteria from growing when a child's taking an antibiotic.
There are certain oligosaccharides, like certain sugars in the breast milk that are designed to basically feed and grow what ends up being a more diverse microbiome.
The bacterium longum infantis, when you add it into babies that are born prematurely in clinical trials, demonstrates a significant improvement in the digestion of breast milk and a significant improvement in immune development in the gastrointestinal lining, in the gut wall. The immune cells look much stronger, much more robust when B. infantis is there.
And so we think B. infantis, as you pointed out, is incredibly good at eating these complex sugars that are in breast milk.
Maybe it's focus on maternal health while you're pregnant and find a way to add the B. infantis to, a prenatal regime. And that way we are front-loading the ability to have a stronger and more robust microbiome.
Right now, as far as I'm aware, nobody's done that one experiment.